In this video, we're going to look at the final part of the Algebra 2 review. Now, if you missed part 1 or part 2, no worries. I'm linking them below for you so that you can easily access them. So don't forget at the end, when you finish all of the problems, you'll want to turn that in to your teacher so that you get your extra credit. Also, remember the purpose of our review is so that you have the review sitting right here while you take the test. Problem 1 on the review goes with problem number 1 on the test. You really want to look at them side by side. So I hope that helps you. If we haven't met, my name is Dr. May, and I am on a mission to help students feel confident in their math class. So that's part of this is I want you to feel confident when you take that final exam. But let's go ahead and dig in. Don't forget, you're going to need something to write with as well as your review paper. You'll also probably want to pull up Desmos graphing calculator. I've linked it below in the description for you. So if you need that link, go ahead and do that and we'll get started. Now, looking at problem number 1 here, we are trying to solve a natural logarithm. That's what the LN stands for. I want to point out that we have a plus in here between two logarithms. When we see a plus with two logarithms, we can multiply what is inside. So I'm going to have the ln of 5 and times 2x. So I took what was in this logarithm, what was in this logarithm, and now I'm multiplying them together. So 5 times 2x will give us 10x. Now, I want you to remember that the natural logarithm has a base of e, and I'm going to write it right here. What we're going to do, friends, is turn this to an exponential. We're going to do e to this power equals what's inside the logarithm. So let me review that again. It's e to the power of 4 equals what's inside the logarithm. And so now all I have to do to solve for x is to divide by 10 on both sides. So x equals e to the 4th divided by 10. Now we're being asked to round our answer to the nearest 100th. So let me switch our view over to Desmos calculator so that you can see that. I'm going to type it in my calculator. E, now to get to the exponent, you're going to do shift 6 to get the caret, divide, and then put the 4. Now, use your right arrow to come out of the exponent and then divide by 10. And so this is how I'm going to get, and rounding to the nearest hundredth, 5.46. Okay, so just a reminder, when we want the exponent, I've got to do shift 6. That'll put me in the exponent. And then I've got to use my right arrow to come out of the exponent. So I hope that helps. All right, number 19 then. We're going to write an equation for the translation of this function so that it has an asymptote at x equals 3 and a horizontal asymptote at y equals 4. Okay, so here we go. Here's our equation they gave us. In order to get the asymptote at x equals 3, that's going to be in the bottom of our fraction. And so we have x equals 3, but we want to have x minus 3 in our denominator. So I'm going to make that change, put a minus 3 there. And then we want a horizontal asymptote at 4. So let's see, that's going to be in the top. Now, in order to get a horizontal asymptote, if I have an x in the denominator, I would also need an x in the numerator. That's to get a horizontal asymptote at 4. And then I've got to have a times 4 and a times 4 out here in front. See, because what I do to the top of my fraction, I've also got to do to the bottom. Let me fix that. That's not quite right. I want a 4. Oops, I met my eraser here. I want a 4. So when I have a 4 here, then what I need is that 3 to go away. So I'm going to put a 3 here. My mistake. Okay. So what's going to happen when I fix all of it? I've got 12x over 3 times x minus 3. Now, the Vertical asymptote at x equals 3. You can see my x minus 3 is right there. The horizontal asymptote comes from what we call the leading coefficients. See, that's why I needed these two to divide to give me 4. And that's taken care of with this function. So this would be my final answer here. Watch your asymptotes. Remember, the vertical ones come from the denominator, and the horizontal ones come from those leading coefficients. Okay, so let's take a look at this graph. We want a graph of the rational function. Now, I know you may be thinking, put it in the Desmos, put it in Desmos. I'm going to, but I want to get a few things first that are pretty standard that aren't going to show up in Desmos. And that's from the denominator. I want you to see these guys here, x minus 2 equals 0 and x plus 2 equals 0. It's pretty easy to see x equals -2 and x equals 2. But why these don't show up on Desmos is because they're vertical asymptotes. They're not actually part of the graph, but they kind of dictate where we can graph each piece. So I want to get those graphed first, so I kind of have some guidelines before I switch over to Desmos so I can see what the rest of the graph was looking like. So I'm going to be real careful when I put these in, x minus 3, x plus 1, and then I've got divide by x minus 2, x plus 2. And you see now what my shapes look like in the middle of my graph. So I'm going to get the general shape from Desmos, but I needed to see those guidelines. I needed to see those asymptotes there at 2 and -2. So keep that in mind as you're working through these. You want to make sure that you've got your guidelines, but then use Desmos to get some of your exact values. I think that's where it's going to produce the best graph for you. That's where we combine our technology with your work, because you've got to have both of those. Just putting it in Desmos is not really going to give you all of those guidelines, those imaginary lines that are guiding where the function can be, but not necessarily showing up on the graph in Desmos. All right, 21 here. What are the points of discontinuity? Discontinuities are where the function does not exist. They always come from the denominator. So you're going to take your denominator and set it equal to 0. That's where you're going to find your discontinuities. Friends, this is where you want to factor. So you're going to ask yourself, what two numbers will give me -7, but add to give me +6? What two numbers multiply to give me -7, but add to give me +6? That's got to be +7 and -1. And then you're going to set each of these equal to 0. So pretty easy, you can subtract 7 over here. Pretty easy, you can add 1 over here. These are your points of discontinuity. Oh, not a red here. How about an orange? Okay, these are your 2 points of your x values for the points of discontinuity. So make sure in your notes you might want to add, hey, points of discontinuity come from the denominator, the bottom of the fraction. All right, problem number 22. What is the quotient? All right, so when we divide fractions, you're going to remember this from your work in probably elementary school, middle school. When you divide fractions, you flip the second one and you multiply. So I'm going to go ahead and flip that second one and multiply. Now, the key thing here, after you flip it and multiply, you want to factor everything that you can. So let us begin factoring this top. On the left here, I see they both have a 2x. So I'm going to factor out a 2x. And that leaves me with 2x minus 1. Now I'm going to factor bottom left. What two numbers multiply to give me 4, but add to give me 5? That's got to be 4 and 1. This is all about factoring here at this point. All right, factor the top right. What two numbers multiply to give me 1, but add to give me 2? That's 1 and 1. And then you've got a 2x down here. Okay, so now it's probably easiest to do our state the restrictions. Okay, so look at your denominators. Remember, discontinuities come from denominators. So let's see, x can't be 0. X can't be -1. And x can't be -4. I'm hoping you saw how I changed those signs, made it just a little bit easier. Really what I was doing is setting it equal to 0. But now you're going to get to cancel things. Now, directions here. You can cancel top and bottom. You can cancel diagonals. So I see these two x's are on diagonal from each other. They cancel out. I see these x plus 1s are on diagonal from each other. They cancel each other out. Now I'm left with the things on top. That's my 2x minus 1 and my x plus 1 and my 1 atom on the bottom, which is my x plus 4. And there you go. I've simplified it and I've stated my restrictions on the variable. All right, let's look then next at a complex fraction. Now, in a complex fraction, I find the easiest way to do it is to look for the common denominator. Now, I'm not going to actually make a common denominator, but looking for the common denominator will definitely make my problem a little bit simpler. So look at the fractions in this problem, 1, 2, and 3. Tell me what would be the common denominator if I was going to make one. Well, I've got an x here, and I've got an x plus 6. So looks like that would be my common denominator. Now, what I'm going to do then, and I'm going to change colors because I want it to stand out for you. I'm going to multiply each of the fractions by that common denominator. You may be saying, well, why would you do that? That's a lot of work. Well, you're right, it is, but I'm going to do it because it actually clears a bunch of the fractions for me, and it'll show here in just a second. I am purposely doing them in different colors so it will stand out a little bit, especially for your notes part. I like for it to kind of resonate with you that that's what we did when you look back at this, especially when you get ready to take your final exam. Okay, now remember, we can cancel on the diagonals. So look at this x plus 6 and this x plus 6 cancel. And it leaves me with x times x, which is x squared. Look at the denominator. See how the x's cancel here and here? That leaves me with 2 times x plus 6. Then I've got plus, and then see the x plus 6 cancels. Give me just an x. See how I got rid of the fraction within a fractions just by doing that? Now let's finish up by distributing that 2 in the denominator. That gives me 2x plus 12. And then we can add the 2x and the x in the denominator. We'll have 3x plus 12 down there. And that would be my final answer. Okay, but let's recap. What did we do there? We found what would be the common denominator if we were going to make one, even though we didn't. We went through and multiplied each fraction by that would be common denominator. And then we let the canceling happen. And we got a much simpler fraction to deal with. All right, look at this one. We're going to do the difference. So I want to, it looks very complicated, I'll be honest with you, but I want to start by factoring everything first. So let's factor this top left. I need two numbers that multiply to give me -15, but add to give me 2x. That's going to be +5 and -3. Okay, let's do bottom left. I need two numbers that multiply to give me -6, but add to give me -1. That's going to be -3 and +2. All right, now I've got going to factor x squared plus 4x minus 12. So I need two numbers that multiply to give me -12, but add to give me 4. That's x plus 6 and x minus 2. And then bottom right, we're multiplying to give me 42, but adding to give me 13. That is 7 and 6, friends. Now, I have some canceling I can do before we even subtract. Just by factoring, remember, we can cancel top to bottom. Ta-da, ta-da. And we're left with x plus 5 over x plus 2 minus, and then x minus 2 over x plus 7. So we need a common denominator. Our common denominator is going to be the x plus 2 times the x plus 7. So we're going to multiply this first fraction by the x plus 7. And we're going to multiply this second fraction by the x plus 2. All right, let's see what happens. Now I'm going to add a few parentheses here just because we need to be reminded that when we multiply these together, we do have to use the FOIL method. Okay, so let's deal with the top. Let me grab a pen here. Deal with the top. I've got x plus 5 times x plus 7 minus x minus 2, x plus 2, and that's all x plus 2 times x plus 7. Okay, so let's multiply this guy out. X times x is x squared. X times 7 is 7x. 5 times x is 5x. And 5 times 7 is 35. Now I've got a minus, so I'm going to be real careful by putting a parentheses there. Let's do x times x is x squared. X times 2 is 2x. Negative 2 times x is negative 2x. And negative 2 times 2 is negative 4. Now, I'm purposely not going to multiply out the denominator. Most of the time we don't. Although if you find that the final answer does, you can definitely do that. So let's look at our numerator. I've got x squared plus 7x plus 5x plus 35. Now I'm going to distribute the minus here. So it's minus x squared minus 2x plus 2x plus 4. Change all the signs in that second parentheses in the numerator. All right, now we need to collect some like terms on top. X squared and x squared cancel out. Then I've got 7x, 5x makes 12x, minus 2x is 10x, plus 2x is 12x. And then I've got 35 plus 4 gives me 39. Don't forget the denominator on the bottom there. All right, friends, lots of opportunities there to be real careful. Watch your minus, make your common denominator. Whew. Take your time on that problem. Okay, it's going to be one you want to spend some extra time on. All right, one more, number 25. This one will be our last one we'll take a look at here. Now, for this one, I also want you to think about that would-be common denominator. Now, for this one, we're not actually going to make a common denominator, but I'm going to use it. So I see that each of the denominators are different. So I'm just going to use that as my common denominator. When we multiply all three of them together, I get my would-be common denominator. Okay, just like we did in the complex fraction, I'm going to multiply each term by that, each fraction by that would-be common denominator. I'm purposely doing them in different colors because I like for it to stick out, just like I said before. I like for it to stick out what we're multiplying by. I don't do that all the time. I don't write it out all the time like this, friends, but for my note's sake, I want a good example that has all of those wonderful steps with it. Okay. All right, let's look for some canceling because you know that's what this is all about. I see my x minus 3's cancel. I'm left with 6 times x plus 6. Plus, I see my x plus 6's cancel. 6 times x minus 3. Then I see my 6's cancel, and I'm left with x minus 3 times x plus 6. Much better equation to solve because I don't have the fractions. So let's distribute here 6x plus 36 plus distribute here 6x minus 18. And then, of course, FOIL here. That'll give me x squared plus 6x and negative 3x minus 18. Okay, let's condense. Let's see, that's 12x. And that is to our 18. And then over here, I've got 3x when I add the 6x minus 3x. And then we want to get everything on one side. So let us subtract the 12x and subtract the 18 so that I get 0 over here equals x squared minus 9x minus 36. And this is where you're going to want to factor, right? So what two numbers will multiply to give me negative 36 but add to give me negative 9? That's going to be negative 12 and positive 3. So if you set each of those parentheses equal to 0, you'll get x equals 12 and x equals negative 3. So those are my solutions here. So I hope this helps. Don't forget, if you missed part 1 or part 2, I've got those linked in the description below. If you have questions or comments or something you'd like to see another example of, I'd love for you to leave a comment. And if you don't mind, you always help me out by hitting that like and subscribe button. Thanks so much. Bye for now.